Introduction. Students, today I am going to teach you three-dimensional geometry. Has anyone heard about it before?
Teacher, I have heard about the 3D glasses which we wear while watching 3D movies.
Yeah, you're right. You are probably familiar with two-dimensional Cartesian geometry by now. That is, planar geometry. With this, we will learn about three-dimensional space or solid geometry. Real-world objects exist in three dimensions. For example, a cuboid or a box is completely described by three parameters as follows: length, breadth, and height. Corresponding to that, each point in the Cartesian space has three coordinates: x, y, and z. Look at this figure carefully. The x-axis is along the length of the screen, the y-axis is along the height of the screen, and the z-axis will be the one coming out of the computer screen. Objectives. At the end of this lesson, you will be able to define coordinate axes and coordinate planes, explain coordinates of a point in space, find distance between 2 points and explain coordinate axes and coordinate planes. Let us take an example of a bouncing ball in a room where one corner of the room is considered as the origin. We can take any corner of the room as origin of reference, and relative to that the coordinates of the point change. Thus, the origin can be taken arbitrarily at any point of the room. Let us start with an arbitrary point O in space and draw three mutually perpendicular lines x dash OX, y dash OY, and z dash OZ through O. The point O is called the origin of the coordinate system, and the lines x dash OX, y dash OY, and z dash OZ are called the x-axis, the y-axis, and the z-axis respectively. The positive direction of the axis is indicated by arrows with thick lines. The plane determined by the x-axis and the y-axis is called xy plane, that is, XOY plane, and similarly YZ plane, that is, YOZ plane, and ZX plane, that is, ZOX plane can be determined. These three planes are called coordinate planes. The three coordinate planes divide the whole space into 8 parts called octants, coordinates of a point in space. Let P be any point in space. Through P, draw perpendicular PL on XY plane meeting this plane at L. Through L, draw a line LA parallel to OY cutting OX in A. If we write OA is equal to X, AL is equal to Y, and LP is equal to Z, then X, Y, Z are the coordinates of the point P. Again, if we complete a rectangular parallel piped through P with its three edges, OA, OB, and OC, meeting each other at O and OP as its main diagonal, then the lengths OA, OB, OC, that is, X, Y, Z, are called the coordinates of the point P. The coordinates X, Y, and Z of any point are the perpendicular distances of P from the three rectangular coordinate planes YZ, ZX, and XY respectively. Thus, given a point P in space, to it corresponds a triplet X, Y, Z called the coordinates of the point in space. Example: name the octant where the given points lie: 2, 6, 8. Minus 1, 2, 3. Solution. Since all the coordinates are positive, therefore 2, 6, 8 lies in the octant OXYZ. Since distance between 2 points, we use the Pythagoras theorem to derive a formula for finding the distance between 2 points in 2 and 3-dimensional space. Let P is equal to x1, y1 and Q is equal to x2, y2 be 2 points on the Cartesian plane as shown in the figure. Then from the Pythagoras theorem, we find that the distance between P and Q is PQ is equal to square root of x2 minus x1 square plus y2 minus y1 square. In a similar way, it can be proved that if P is equal to x1, y1, z1 and Q is equal to x2, y2, z2 are 2 points in the 3-dimensional space, the distance between P and Q is P. Example 1. Find the distance between the points 2, 5, minus 4 and 8, 2, minus 6. Solution. Let P 2, 5, minus 4 and Q 8, 2, minus 6 be 2 given points. Therefore, PQ is equal to square root of 8 minus 2 square plus 2 minus 5 square plus minus 6 plus 4 square is equal to square root of 36 plus 9 plus 4 is equal to square root of 49. Example 2. Show that the points minus 2, 3, 5, 1, 2, 3 and 7, 0, minus 1 are collinear. Solution. Let points minus 2, 3, 5, 1, 2, 3 and 7, 0, minus 1 be denoted by P, Q and R respectively. The points are collinear if they lie on the same line. PQ is equal to square root of 1 plus 2 square plus 2 minus 3 square plus 3 minus 5 square. After calculating PQ, we get square root of 14. PR is equal to square root of 7 plus 2 square plus 0 minus 3 square plus minus 1 minus 5 square. After calculating PR, we get 3 into square root of 14. QR is equal to square root of 7 minus 1 square plus 0 minus 2 square plus minus 1 minus 3 square. After calculating QR, we get 2 into square root of 14. Here, PQ plus QR is equal to square root 14 plus 2 into square root 14 is equal to 3 into square root 14 is equal to PR.